Underpinning, strengthening existing foundations. A building is only as strong as the ground it stands on. But what happens when the ground shifts or the foundation weakens over time? That's where underpinning comes in, a powerful technique that gives structures a second chance by strengthening or deepening their foundations. Whether you're dealing with settling soils, expanding buildings, or structural upgrades, underpinning plays a crucial role in preserving the integrity of existing foundations. What is underpinning? Underpinning is the process of reinforcing an existing foundation to make it stronger or deeper. It's typically used when the original foundation is no longer strong enough to support the structure, whether due to changes in soil conditions, additional loads, or design flaws. The goal is to transfer the load of the building to deeper, more stable soil layers or to increase the overall bearing capacity of the foundation system. When is underpinning needed? There are several scenarios that may call for underpinning. For instance, if the soil beneath a building shifts or compresses over time, parts of the foundation may sink unevenly, leading to cracks and structural damage. Adding extra floors or changing the building's use can introduce new loads that the old foundation wasn't designed to handle. Excavations near the foundation, water table fluctuations, or poor compaction during initial construction can lead to foundation instability. Additionally, natural disasters such as earthquakes, floods, and landslides can weaken the ground beneath a structure. In all these cases, underpinning becomes a preventive or corrective solution to restore stability and safety. Signs that underpinning may be necessary. Early detection is key. There are some telltale signs that a building may require underpinning. These include cracks in walls, especially diagonal ones near doors or windows, sloping floors or noticeable unevenness in the interior, gaps between walls and ceilings or floors, sticking doors and windows, and evidence of foundation movement like separation from adjacent structures. When these signs appear, a professional assessment is necessary to determine whether underpinning is the best solution. Types of underpinning techniques. Several underpinning methods exist, each suited to different structural and soil conditions. The most common and straightforward method is mass concrete underpinning, also called traditional underpinning. Small sections beneath the existing foundation are excavated and filled with concrete one at a time, gradually extending the foundation's depth and load-bearing capacity. In mini-piled underpinning, which is ideal when loads are heavy or access is limited, small diameter piles are drilled deep into the ground and connected to the foundation using a reinforced concrete beam. This method works well in poor soil or where ground movement is expected. Another technique is beam and base underpinning. In this method, a reinforced concrete beam is constructed below or above the existing footing and connected to new concrete bases that transfer the loads to stable soil. It offers more flexibility in design compared to mass concrete. Screw pile underpinning involves driving screw piles into the ground and attaching them to the foundation to stabilize or lift the structure. This method is fast, produces minimal vibration, and is especially useful in residential settings. Jet grouting is also sometimes used, where high-pressure jets inject grout into the ground to strengthen weak soils beneath the foundation. This is more of a soil improvement technique, but can be useful in underpinning when needed. The underpinning process. Underpinning requires a detailed site assessment followed by careful planning and execution. The process begins with a thorough assessment, where engineers analyze the structure, soil, and cause of the problem. Based on their findings, a suitable underpinning method is chosen. Execution is carried out in small stages to maintain stability, and monitoring is done throughout to detect any unexpected movement. Once the work is complete, the area is restored, and any cosmetic repairs such as crack repairs are made. Safety and precision are critical at every stage. Risks and benefits. While underpinning is highly effective, it also comes with risks. If not done properly, it may cause further movement or instability. Vibrations and noise during work can affect surrounding buildings, and the cost and time can be significant depending on complexity and access. This is why it's essential to hire experienced professionals and follow local building codes strictly. Despite its complexity, underpinning offers powerful benefits. It restores structural integrity and prevents further damage. It makes it possible to safely expand or modify a building. It increases the lifespan and value of the property. Most importantly, it allows buildings in historic or sensitive areas to be preserved rather than demolished. It's a long-term investment in safety and performance. Conclusion: underpinning isn't just a technical fix, it's a structural lifeline. When a building starts to falter, underpinning offers a way to reinforce what lies beneath and ensure the entire structure stands tall for years to come. Whether it's dealing with settling soils or preparing for expansion, this powerful technique remains one of civil engineering's most reliable solutions. Thanks for tuning in to Blueprint to Reality. If you enjoyed this deep dive into foundation strengthening, give us a like and share your thoughts in the comments. Don't forget to subscribe for more civil engineering breakdowns made simple. Until next time, keep your foundation strong and your vision grounded.